So, my topic is generation of induced EMF by changing the angle theta between area vector and B vector, that is magnetic field vector. Okay. Let us consider a coil of n turns, right? So, placed in a magnetic field B. Okay, and rotated about an axis, so that the angle theta between the area vector and B vector changes continuously. Let us consider a coil of n turns. How many turns? N turns. Be placed in a magnetic field B and rotated about an axis so that the angle theta between the area and the magnetic field changes continuously. Always changes. So there will be some axis and the coil will rotate, okay, so that its value, that is angle theta, always change with time. Okay, so let us draw the figure. Let us see how it works, because everything can be explained with the help of a figure. Okay, let this be the magnetic field. Okay, so magnetic field. Magnetic field is directed like this. So if the coil rotates and it's about an axis passing through the, which is perpendicular to this blackboard, and it must be perpendicular to the magnetic field direction. It is the axis is perpendicular to the magnetic field also. The area, that is the normal drawn on the area of the coil, okay, drawn on the plane of the coil, this is the normal, which will give area, that is aerial direction. This normal gives the direction of this area of the coil. So coil rotates about this axis passing through the point O. Okay. So the angle theta, which is the angle between magnetic field and the area. Okay. So this direction makes an angle theta. So if coil rotates about this axis, which is passing normally to this blackboard, suppose it is rotating like this or rotating like clockwise direction. In any case, either clockwise or anti-clockwise, if it rotates, this angle will change. As soon as this angle changes, what will happen? As we know that the magnetic flux is given, B A N cos of theta, right? So when theta changes, okay, all other remains constant. N is constant, area is constant, B is constant. So area of the coil remains constant. So the value of the magnetic field is also constant. By rotating the coil, we are changing the value of theta at all time. So, according to Faraday's law, second law, the induced EMF is given by minus d phi by dt. Okay. So this is the relation between induced EMF and the magnetic flux. The rate of change of magnetic flux, okay, the rate of change of magnetic flux gives the magnitude of induced EMF. So it is the induced EMF. So now, if we put the value of phi, that is magnetic flux, okay, what will get? This value will be observed after simplification. Let us put the value phi B A N. N is the number of turns in the coil. Okay. So as you know how to differentiate, all the constant quantity will come out, right? So minus B is a constant, A is a constant, N is a constant. Differentiation of cos theta is what? Minus sin theta. Okay. Differentiation of cos theta is nothing but minus sin theta, right? So minus minus will be plus B A N. Just a minute. This is we cannot differentiate theta as soon as it is t, right? So we have to convert it to omega t. Omega t. I'll tell you what is omega. Okay, because it is theta, it is t. So we have to differentiate theta. So we have to transform theta into omega t, right? So in that case we can differentiate. Otherwise we will not be able to differentiate, right? So putting theta as omega t, it is theta no doubt. So we have to put theta as omega t. Okay. Then let me explain it by using another line dt. So BAN will come out no doubt. BAN will come out. And dt, it is cos omega t, right? So what is omega? Omega is the angular velocity of the coil. Conic বেগ, angular velocity. Conic বেগ মানে কাক কয়? Conic হরণ theta, angular displacement divided by time. Okay. So theta is equal to omega t, right? So in place of theta you can write omega t. Okay. So it comes from the angular velocity relation. Angular velocity is given by rate of change of angular displacement. Okay. Theta is the time in theta is the angle made in time t. Then theta will be omega t. So now we can differentiate. Okay. Now we can differentiate. After differentiation, what we will get? We will get V minus minus will be plus VAN. Differentiation of cos omega t is sin minus sin omega t, and again you have to differentiate omega t. If you differentiate omega t, you will get omega, right? Sin omega. Okay. So this is the value. What is the value? The EMF is given by B A N omega sin omega t, right? So B A N omega sin omega t. Okay. And we can write it as epsilon naught sine omega t, or in sometimes we will write it E naught. Okay. So what is epsilon naught? Equation 1, where epsilon naught is equal to V A N omega, right? Maximum EMF. The maximum value of EMF is given by this value. Why maximum? If sine with omega t is equal 90 degree, that is theta is equal 90 degree, okay, then sine 90 will be 1, okay, sine 90 will be 1. So if this is 1, then epsilon, that is EMF, will be equal to this value. So this value is written as epsilon naught or E naught. In some books you will get it E naught, no problem. Epsilon naught is nothing but B A N omega. Okay, so this gives the peak value of EMF, because the nature of this induced EMF is sinusoidal. If this is equation number 1, this is equation number 1. So does the nature of the induced EMF is sinusoid. What does it mean? It means that this will be like this sine curve. Okay, ups and down, because it consists of sine. Okay, from this we can conclude that the nature of the induced EMF, যেটো induced EMF produce hobo, সেইটো sine curve hobo, because sine is there. Okay, so if induced EMF is sine, then induced current will also follow the same relation, sine omega t. So this will lead you the alternating current. The next topic will be alternating current. So starting from the production of induced EMF, we will get alternating current also, because induced EMF will give induced current, right? If you connect this source of EMF with some external resistance, then it will send current through the resistance. That current will be induced current. So how we will get this sinusoidal curve from this? Suppose if this rotates, if it becomes theta becomes 90 degree, okay, theta becomes 90 degree, what will happen? This becomes epsilon naught, that is peak value. Okay, and if theta goes again to 180 degree, okay, what will happen? Theta again goes to 180 degree, again it will be 0, right? So this will give you the alternating current generation, right? So if coil rotates at different positions, you will get different value of EMF. Okay, so see, you have this relation, okay, sine omega t. You have this relation. So omega t is nothing but theta, right? So if you find here the value, different values here, okay. So omega t becomes suppose omega t here, omega t, that is theta, which is equal to theta, and epsilon, the value of EMF and the value of angle. When it is 0, when the angle during the rotation, coil to ঘূৰি থাকিব এটা পজিশনত when theta is equal 0. When theta is 0, you put the value of 0. So induced EMF will be 0. Sin 0 is equal 0. It will be 0. When omega t that is equal to theta, omega t is nothing but theta. If theta is equal 90 degree, that is pi by 2, what you will get? Pi by 2, sin pi by 2 is equal to 1. So epsilon is equal epsilon. Maximum value, peak value. Okay. So again, you come 90 degree. Okay. Then 90 degree, then 180 degree. What will happen? It will be again 0. Okay. 270 degree. Okay. Times pi by 2. 270 degree. If theta is equal to 270 degree, what will happen? It will be minus 1. Sin 270 degree is equal minus 1. The minus 1 is equal, it will be minus epsilon naught. Right? Similarly, the last value, if you put twice pi, last value twice pi, it will be again 0. Okay. So if you draw a graph, so this indicates this point indicates pi by 2, this point indicates pi, twice pi, this point indicates thrice pi by 2, this point indicates twice pi, this is pi, twice pi. So then for EMF, induced EMF in this direction omega t, that is theta. So for this value, you will get maximum value. Suppose this point is epsilon naught, maximum value. This point is minus epsilon naught, maximum value in the opposite direction. So one point will be here, another point will be here, another point will be here, next point will be here. So your graph, if you draw the freely, you will get like this. This is sinusoidal graph. Okay. So by changing the orientation of the coil, you can produce induced EMF by following Faraday's second rule, second law, right? And that induced EMF produces in turn induced current. That induced EMF as observed is sinusoidal in nature. Okay, and which in turn indicates that the current obtained from this induced EMF is also sinusoidal, right? So this is the way how to produce the induced EMF by changing the orientation of the coil, that is by rotating a coil. Okay.